Okay, good morning to everyone. My
Good
voice is
morning,
clear to
sir.
everyone.
Good morning, sir.
Hello, my voice is clear.
Yes, sir.
Yes, sir.
Sir.
Okay, screen is visible to everyone.
Yes, sir.
दीजी का मेरा voice clear है.
Yes, sir. Voice clear है.
Hello.
Yes,
Yes,
sir. Voice
sir.
clear है.
Hello.
Sir, voice clear है.
Hello.
Sir, your voice is clear.
Okay. And I taking the class of transducer. And what is transducer? Actually, transducer is a device which is convert the physical quantity into proportional electrical signal is called transducer. And I give the explanation of different type of transducer, which is primary transducer, secondary transducer, active transducer, and passive transducer, and analog transducer, and digital transducer. Okay, and also discuss about the strain gauge and LVDT. Strain gauge and LVDT. So mostly LVDT and strain gauge, and just 1 second. And another is that the transducer uses many effects produced such as conversion and the process of transforming signal from one form to another or other is called transduction. Transduction. And the transducer, also called pickup and transduction element, transform the output of the sensor to an electrical output as shown in the figure. And transducer are two part or the main component. First, three main component. First part is the sensing element, and second part is the transduction element. Sensing part sends the and produce the response, and transaction part is the conversion take place in this part. And classification of transducer I already discussed. There will be active, passive, primary, secondary, and analog or digital. So some transducer, according to the principle of operation, according to their principle of operation, transducer are listed below as a resistive transducer, capacitive transducer, and inductive transducer, and voltage and current transducer. Okay, so first one is the resistive transducer. Resistive transducer is the under the category of strain gauge. I already discussed about the strain gauge principle with a equation. So strain gauge, what is happened in strain gauge? In the strain gauge, the change of the value of resistance metal of the semiconductor due to the elongation or the compression is known by measurement of torque or displacement or force. So resistive transducer में क्या होता है, जो strain changes होता है due to the elongation or the compression of the strain or the change of the resistance. This is the resistive transducer. And resistive strain gauge, the change in the value of resistance metal in semiconductor due to the elongation or the compression is known by measurement of torque, displacement or force. Next one is that resistance thermometer. This is also depends on the resistance and the change of the resistance of the metal wire due to the change in temperature, and by using this method we can measure the temperature. Then resistance hygrometer, this is also the same. Due to the change of resistance of conductive strip due to the change of moisture content is known by the value of its corresponding humidity. So hygrometer is used for measurement of humidity. And next one is that number 4 is that hot wire meter. Hot wire meter is also the change in resistance of the heating element due to the conversion of cooling of the flow of gas is known its corresponding gas flow or the pressure. So using hot wire instrument or hot wire meter we can measure the gas flow or pressure of a gas. By the principle depends on the changing the resistance of the heating element, and this is the changes is happened due to the cooling of the flow of gas is known by its corresponding gas flow or pressure. Number 5 is the photoconductive cell. Photoconductive cell, the change in resistance of the cell due to the corresponding change in light flux is known by its corresponding light intensity. So photoconductive cell में क्या होता है, ड्यू टू द चेंज इन रेजिस्टेंस चेंज के कारण वो क्या होता है, द चेंज ऑफ रेजिस्टेंस ऑफ द सेल, जो रेजिस्टेंस ऑफ द सेल का जो फोटोकंडक्टिव सेल का जो रेजिस्टेंस चेंज होता है तो कॉरस्पॉन्डिंग चेंज ऑफ लाइट फ्लक्स का चेंज के कारण मेरा रेजिस्टेंस जो फोटोकंडक्टिव सेल का जो रेजिस्टेंस है वो चेंजेस होता है, एंड दिस कैन बी मेजर्ड बाय इट्स कॉरस्पॉन्डिंग लाइट इंटेंसिटी. Number 6 is the thermistor. Thermistor, the change in resistance of semiconductor that has negative coefficient of resistance is known its corresponding measure of temperature. So using thermistor, the thermistor में क्या होता है, the change in resistance of semiconductor that has the negative coefficient of resistance is known its corresponding measurement of temperature. Negative coefficient means क्या है, कोई बता पाओगे? Negative coefficient of resistance means, hello
Yes, sir.
हेलो दीजी का तुम्हारा आवाज नहीं आ रहा है मेरे पास, क्यों हमको समझ में नहीं आ रहा है.
Sir, side में
हम तो सब कुछ अलाउ करके रखे हैं यहाँ पर.
Hello, sir.
जस्ट 1 सेकेंड, फिर से बोलो तो.
Hello, sir.
Hello.
Sir, I'm audible? Hello.
Hello, sir.
Okay. And last one is the potentiometer type. The change in resistance of the potentiometer reading due to the movement of slider as a part of external force applied is known by its corresponding pressure or displacement. So potentiometer type transducer can using transducer we can measure the corresponding pressure or displacement. And next one is that capacitance transducer or capacitive type transducer. So capacitance type transducer, what is the working principle of this type of transducer is that the principle of operation is that the distance between two parallel plates is varied by externally applied force application. So measurement of displacement, pressure, okay. So application, so variable capacitance pressure gauge. Number one is the variable capacitance pressure gauge is that in this pressure gauge means this is the part of capacitance transducer. This is the part of capacitance transducer. The principle of operation, the distance between two parallel plates is varied by an externally applied force application. तो जो इसका जो ऑपरेशन क्या है, दो पैरेलल प्लेट में प्लेट में डिस्टेंस मेजर करते हैं एंड द प्लेट जो पैरेलल प्लेट वेरीड ड्यू टू द applied external force and the application for measurement of displacement and pressure. Number two, the capacitor of as a microphone. Capacitor microphone, the principal operation that sound pressure of the capacitance between fixed plate and the movable diaphragm, and the application is speech, music and noise, and last one is the dielectric gauge of principle of operation. Dielectric gauge principle of operation is that the variation in the capacitance by changing or changes in the dielectric. The dielectric gauge is the principle of operation is that the variation in the capacitance, it can be changed the dielectric properties, and this is the application of for measurement of liquid level or thickness of the pipe of flow pipe. Next one is the inductance transducer. Inductance transducer, this is the first one is the magnetic circuit transducer principle of operation. Magnetic circuit transducer principle of operation is that self induction or mutual induction of AC excited coil is varied by change in magnetic circuit. An application of that, it can be using, we can measure pressure or displacement. The self-inductance or the mutual induction of the AC excitation coil is varied by change of the magnetic circuit. So inductive transducer is the first one is the magnetic circuit transducer, which the principle of operation is that the self-inductance or the mutual inductance of AC excited coil is varied by change in the magnetic circuit. And application and pressure and the application is that the pressure and displacement can be measured by using this type of transducer. And number two is the reluctance pickup transducer, and the principle of operation that in reluctance type transducer the magnetic circuit is varied by changing the position of iron core. So just an example of LVDT. LVDT is the core is movable due to the magnetic flux is generating or excitation due to the AC supply, and the cold position, it's the potential difference is depends on the potential difference is depends on the cold position. Okay, just you remember the LVDT working principle. So with using this type of transducer, you can measure pressure, displacement, vibration, and position. And differential transformer type of uh, number 3 is the differential transformer type of transducer, which is the principle of operation is that the difference voltage of two secondary winding of a transformer is varied by positioning the magnetic core through an externally applied force. Through an externally force application is that it is also used for pressure, force, displacement, and position measurement. It is also used for, you know, so LVDT में क्या होता है, एक प्राइमरी ट्रांसफार्मर रहता है और दो सेकेंडरी कॉइल रहता है, and the core is between them. If the core is due to the external force, core is moved, then the potential difference between 2 points is changes, so we can easily, and the output signal is voltage signal, and then we can easily measure the displacement of the core or displacement of any requirement as our requirement. And AD current gauge principle, in this the principle of operation is that the inductance of the coil is varied by proximity of an AD current plate. It is also used for measurement of displacement and thickness of the flow pipe. And last one is the magnetoresistance gauge of principle of operation. The magnetic properties are varied by pressure and stress. The magnetic properties are varied by pressure and stress. So जो मैग्नेटिज्म प्रॉपर्टी है, जो मैग्नेटिक प्रॉपर्टीज है वो वैरी करते हैं ड्यू टू द अप्लाइडिंग प्रेशर और फोर्स. So you can measure using the this type of transducer, the inductive transducer, for measuring force and pressure and also sound. And next one is the voltage and current transducer. Current transducer. Voltage and current transducer. The Hall effect pickup principle of operation is that the Hall effect pickup transducer, the principle of operation is that a potential difference is generated across a semiconductor plate which is made by germanium when the magnetic flux is interact with an applied current. So yeah, in this Hall effect or Hall effect pickup in transducer or Hall effect transducer, इसमें क्या होता है, ये potential difference is generated across a semiconductor plate, across the semiconductor plate which is made by germanium, and when a magnetic flux interact with the applied current, which is potential difference is generated across the semiconductor plate, and when a magnetic flux interact with the applied current. So the magnetic flux and current measurement, we can measure the magnetic flux and current by using this Hall effect type of transducer. Next one is the ionization chamber. Ionization chamber. The principle of operation of for the ionization chamber is that the electron flow induced by ionization of gas due to the radioactive radiation. The ionization chamber is works on the depends on the electron flow induced by ionization gas due to the radioactive radiation. An application for is that it is can counting the particle counting and radiation. Application is that particle counting and radiation purpose. And last, number 3 is the photoemissive cell. In this photoemissive cell, what happened in this photoemissive cell, the electron emission due to the incident of radiation on photoemissive surface. It can be used for light and radiation measurement. It can be used for light and radiation measurement. The electron emission due to the incident radiation on the photoemissive surface. And some self-generating or active transducer is the thermocouple, moving coil generator, and piezoelectric pickup and photovoltaic cell is the self-generating or active transducer. Self-generating and active transducer. So thermocouple, what happened in thermocouple? Thermocouple, there have no external power or required. There are no external power is required. For this reason, this type of transducer is called active transducer. The example of so example is that thermocouple, thermopile. Okay, and in thermocouple type transducer, what happened? A EMF is generated across the junction of two dissimilar metal or the semiconductor when that junction is heated. So this thermocouple type of transducer are used for measurement of temperature, heat flow, and radiation. And another example is that piezoelectric piezoelectric transducer or piezoelectric pickup transducer. In this case, an EMF is generated when external force is applied to a certain crystalline material, certain crystalline material such as quartz, sound. piezoelectric crystal और piezoelectric pickup transducer में क्या होता है? When an EMF is generated, EMF generate होता है तब कब नहीं तो when external force is applied on the certain crystalline materials के ऊपर अगर external force देंगे तब उसके कारण क्या होता है? EMF is generated होता है. Okay, so this is used for vibration, acceleration, and pressure changes. This is due to the pressure changes. And primary transducer and secondary transducer. Primary Barden tube acting as the primary. I already discussed what is Barden tube. Barden tube is a sense and depth the pressure is converted into displacement. So displacement can be measured by the LVDT, and LVDT here is the secondary transducer, and primary transducer is a Barden tube. Barden tube acting as a primary detector or primary sensor. So it is primary transducer, and LVDT is a pressure can be transferred. Pressure can be measured or converted into displacement by LVDT. So this is convert the input to quantity, and analog out is the using strain gauge, LVDT, thermocouple, thermistor. And digital transducer, this transducer convert the input quantity into electrical output in which the form of pulses. So digital transducer क्या है? जो electrical quantity जो है, जो transducer convert the input quantity into an electrical output which is in form of pulses, and glass scale can be read optically by means of light source. And the optical system and the photocell transducer and inverse transducer can broadly defined as a device which convert the non-electrical quantity into electrical quantity, just resistive, inductive, and capacitive. These are the uh, inverse transducer, a normal transducer, and the inverse transducer is defined as a device which convert the electrical quantity into non-electrical quantity. Just example of piezoelectric crystal. Piezoelectric crystal is the example of inverse transducer. Inverse transducer क्या है? Actually जो transducer which convert the electrical quantity into non-electrical quantity. And last one is that advantages of electrical transducer. Advantage of electrical transducer. So mostly the quantity to be measured are जो हम लोग quantity measure करते ज़्यादातर वो non electrical quantity होता है, such as temperature, pressure, displacement, humidity, fluid flow, speed. All are the non electrical quantity, but we can easily measure you using the transducer sensor or some measuring instrument. So these are the non electrical quantity. Okay, but this quantity cannot be measured directly, but these quantities cannot measure it directly, so hence such quantity are required to be sensed and changed into some form of easy measurement. And the electrical quantities such as current, voltage, resistance, inductance, capacitance, etc. can be conveniently measured and transferred and stored and for further use purpose. Therefore, for measurement of non-electrical quantity, these are to be converted into electrical quantities first, and then it is measured. And the function of converting non-electrical quantity into electrical one is accomplished by a device is called electrical transducer. So what is electrical transducer? The function of non-electrical quantity को जो clock electrical quantity में convert करते हैं for measuring purpose. So these are called electrical transducer. And basically an electrical transducer is a sensing device by which the physical, mechanical or optical quantity to be measured is transformed directly with a suitable mechanism into an electrical signal. Conversion means electrical signal means either current, voltage and frequency. The production of this signal based upon the electrical effect which may have resistive, inductive, capacitive, etc. in nature, and the input versus output energy relation takes in definite reproducibility of the function, and the output or the input behavior is predictable to a known degree of accuracy, sensitivity, and response, and within the specified environmental condition. And the electrical transducer have numerous advantages that the modern computer have made use of transducer absolutely essential, and the electrical transducer suffer due to some drawbacks too, such as low reliability in comparison to that of the mechanical transducer due to the aging and drift of active component aging and drift of acting component, and high cost of electrical transduction and associated with a signal condition. In some of case the accuracy and the resolution attainable are not as high as the mechanical transducer. So some of the advantage are electrical amplification attenuation can be done easily, and that with a static device, and the effect of the friction is minimized, and the or electric electronic system can be controlled with a very small electric power. Number 4 is the electric power can be easily used and transmitted and the process for the purpose of measurement. The factor to be considered while selecting the transducer, it should have the high input impedance and low output impedance. So कोई भी ट्रांसड्यूसर सिलेक्शन करने के टाइम हमको ये इसके ऊपर थोड़ा ध्यान देना होगा. It can be noted that the transducer which is selected, it has the high input impedance and with a low output impedance, and to avoid the loading effect, and it should have the good resolution over is the entire selected range, and it must be highly sensitive to desired signal and the incentive to unwanted signal. So required for the good transducer, it is a small in size and weight and high sensitivity and ability withstand of environmental condition and low cost. So this is the basic some parameter, and the working type depends on the transducer, and according to their working type instruction uh, according to their working type, the transducer are classified in capacitive, resistive, inductive, voltage and current, and the some selecting procedure for transducer, and the beta transducer, which is some properties, and the active and passive transducer, and these are the basic part. So now I go to the already strain gauge is completed. So I go to the next part. Just 1 second. Just 1 second. So resistance thermometer or RTD or resistance temperature detector. Resistance temperature detector. So it is another example of this is the resistive transducer. What is the change of resistance? It is the due to the semiconductor, depends on the semiconductor properties. So resistance thermometer, it is well as a resistance of the metallic conductor is increased with the temperature, while that the semiconductor generally decrease the temperature, decreases with a temperature. Generally जो resistance जो generally क्या होता है, due to the changing of resistance of the conductor with directly proportional to the temperature, means अगर मेरा रेजिस्टेंस चेंज करेगा तो टेम्परेचर इंक्रीज करेगा, और टेम्परेचर इंक्रीज करते हैं तो वो मेरा रेजिस्टेंस भी इंक्रीज करेगा. बट इन दैट of the semiconductor case, generally it is decreased with the temperature. Semiconductor case, in case of semiconductor, the resistance is decreases with the change in temperature, and the resistance thermometer is employed a metallic conductor for temperature measurement, which is called resistance temperature detector or RTD. RTD is versatile, used for measurement of temperature in industrial, any industry, in process industry, and it is versatile use. And those employing the RTD is measured used for measuring temperature. And those employing the semiconductor are turned on the thermistor, and the RTD are more rugged and have more, and it is the less linear characteristic of over a wide temperature range, and the other hand thermistor have high temperature sensitive but non-linear characteristic. And सो इसमें दो प्रॉपर्टी है, एक है आरटीडी. आरटीडी में क्या होता है, ड्यू टू द चेंज ऑफ रेजिस्टेंस द टेम्परेचर इंक्रीज करेगा तो मेरा रेजिस्टेंस भी इंक्रीज करेगा विद वाइस वर्सा. बट थर्मिस्टर में क्या होता है, नेगेटिव होता है, मतलब ड्यू टू द चेंजिंग और द इंक्रीज ऑफ टेम्परेचर द थर्मिस्टर रेजिस्टेंस इज डिक्रीजेस. So but in generally used, we are used for mostly used in industry as a RTD because it's the more rugged and have more or or less linear characteristic over a wide range of temperature. On the other hand, thermistor have the high temperature sensitivity, but the scale is non-linear in the characteristic, And the resistance temperature detector, the variation of the resistance meter with the temperature is normally modeled in form of RT is equals to R0 1 plus alpha T minus T0 plus beta T minus T0 square dot ऐसे करके आएगा, and where RT and R0 is the resistance value at T0 degree centigrade, T at T degree centigrade to T0 or T0 centigrade respectively, and alpha beta are the constant, and that depends on the metal. These constants depends on the metal, and the metal for the small, just 1 minute. And for the constant are depends on the metal. So generally the RTD equation is that RT which is the resistance value at T temperature, and R0 is the at the resistance at a when the value when the temperature is T0. So this can be changed due to the T0 is can be and T0 0 T degree to T0, and respectively the alpha and beta are the constant, and this constant depends on the metal. And for small range of temperature, the expression can be approximated as a RT equals to R0 into 1 plus alpha minus T naught 0. So for copper, this constant is depends. This constant is 0. Alpha for copper, alpha is 0.00427 per degree, and the nickel, platinum are mostly used for RTD material. The nickel and platinum are mostly used as a RTD material, and the range of the temperature measurement is decided by the region where the resistance temperature characteristics are approximately linear, and the resistance versus temperature characteristic of the metal is shown in figure with a T0 T T degree to at 0 degree Celsius, and platinum has a linear range of operation up to 650 degree centigrade, while the useful of range of nickel is copper and nickel are range is 120 degree centigrade and 300 centigrade respectively. So the highest range for measuring temperature is used as a platinum for as a RTD material. So because its range is high, means that its range is 650 degree Celsius, and copper is 120 degree, and nickel is 300 degree. And this is the now the construction of RTD for industrial use and where material used can the for industrial use it can be used for measurement of temperature, and they must be protected from mechanical hazards such as material decomposition, tearing, and other physical damages. And the silent features of construction of industrial RTD as follows: that the resistance wire is often put in stainless steel oil with the or oil for protection against mechanical hazard. So RTD को in general RTD इंडस्ट्री में यूज होता है, तो इंडस्ट्री में ड्यू टू द सम मैकेनिकल इफेक्ट और मैकेनिकल हैजर्ड एंड द मटेरियल डिकम्पोजिशन, सो मेरे को RTD को सेफली रखना है for long time uses. Show the silent features of the construction of the industrial RTD as follows: the RTD can be put in a stainless steel oil for protection against mechanical hazard, and this is also useful for the point of view of maintenance, and since the defective sensor can be replaced by a good while the plant good while the good one while the plant is in operation. Okay, and here the heat conducting but electrical insulation insulating the material like a mica is placed between the oil and the resistance material, and the resistance wire should be carefully wounded over the mica sheet so that no strain is developed due to the length expansion of the wire. Length expansion of the wire. So कैसे कैसे डिजाइन करते हैं? फर्स्ट ऑफ ऑल द रेजिस्टेंस वायर इज ऑफ्टन पुट इन ए स्टेनलेस स्टील oil for protection against the mechanical hazard, and this is also useful from the point of view of maintenance also. And since a defective sensor can be replaced by a good one while the plant is in operation, तो plant अगर इसमें अगर कोई डिफेक्ट भी हो गया सेंसर तो उसको हम इजीली रिप्लेस कर सकते हैं, क्योंकि इसको ऑलरेडी एक माउंटेड है, कवर अप है, इसलिए तो कवर अप है। ड्यू टू क्यों कवर अप है? क्योंकि ये मैकेनिकल जो हैजर्ड है उससे इसका कोई हानि नहीं पहुंचे, मतलब ड्यू टू नॉट डैमेजिंग बाय मैकेनिकल हैजर्ड। And next one is the electric heat conducting but the electrical insulating material like a mica is placed between the oil and the resistance material, so heating effect also not damage this RTD. And last one is the resistance wire is wounded, be carefully wounded over a mica sheet so that no strain is developed due to the length of the expansion. So this is the construction of industrial RTD. This is the construction of industrial RTD. Here is the first one. Due to the is it protect the RTD from the mechanical hazard. Then these are the mica. And this is our resistive wire. This is the resistive wire. So ये हमारा पूरा ओंडेड है। इसके बाद माइका देखिए जो इंसुलेटिंग हीटिंग इफेक्ट नहीं करेगा, and the resistance wire should be carefully wounded over the mica sheet so no strain also be developed due to the length expansion of the wire. अगर wire का length expand करेगा due to the mica it cannot be affect the our RTD. Okay. Should signal conditioning that the resistance or variation of RTD can be measured by a breeze. The resistance variation of RTD can be measured by a breeze or directly by the voltmeter method. The resistance variation method change of resistance can be we can measure directly by the breeze by using breeze or directly by using volt ampere method, but major constant is the contribution of lead wire in overall resistance measurement, since the length of the lead wire may be vary and this may be give the false reading in temperature to be measured. So this point is most important point is that, but mostly used for RTD can be used for breeze measurement or directly volt ampere method, but the major constant in the contribution of the lead wire due to the lead effect in overall resistance measurement, since the length of the lead wire may be vary. Lead wire का जो lead जो wire है वो vary करेगा and this can be gives the false reading in a temperature to be measured, and there must be some method for compensation of the effect of lead wire is resistance measurement is eliminated. So this is the breeze. This is the breeze. Which breeze? This is the on type of Western breeze. Okay. So this can be achieved by using 3-wire RTD or 4-wire RTD. ये जो effect है इसको eliminated कर सकते हैं कैसे? By using 3-wire RTD or 4-wire RTD. Both the same of measurement are in shown in figure. This is the 3-wire RTD and this is the 4-wire RTD. 1, 2, 3, 4. So what happened in this case? In 3-wire method, one additional dummy wire is taken from the resistance element, or additional dummy wire is connected. Dummy wire is taken from the resistance element and connected to a bridge. The figure, this figure, and show that two lead wire are is connected to a adjacent arm, just for remembering the Kelvin double bridge working principle. And so it's does the cancelling the each other effect, and the number B figure means the second picture is the 4-wire method of measurement is shown here. It is similar to the 4-terminal resistance. So 2 terminal are used for injecting current, while 2 other for measuring voltage. Just a minute. Okay. So another is method is the thermistor. Thermistor also the follow the same properties, but here the semiconductor type. That in this case, the change of resistance is negative coefficient. With a negative coefficient means if the change in temperatures, then the resistance will be decreases. Resistance will be decreases, but the procedure all are same. LVDT I already covered. Hardware and emitter already covered. Another is thermocouples. Thermocouple. So principle, you all know about the thermocouple, that the principle for the thermocouple is that when two dissimilar metals are conjuncted in operation format of the isolated closed circuit, the current flow when one junction is at higher temperature and other junction is the lower temperature. Okay, so there will be a current flow. So this is the junction. Main one is the hot junction, another is the reference junction, which is cold junction, and the metal is two dissimilar metal, and it is connected to a voltmeter, and it is a heat source which is heated the hot junction. So principle of hot junction. So when two dissimilar metals are such as a connected in a copper and nickel, or form a closed circuit, and current flow when when one junction is at higher temperature and other one is the at a lower temperature, as shown in this figure. So the thermocouple is the principle of measurement by the principle of measurement of the temperature by thermocouples. The thermo EMF driving epic current is called thermoelectric effect of the phenomena is known as a thermoelectric effect or Seebeck effect. This effect is known as a Seebeck effect or thermoelectric effect. Usually the thermocouple emissive type is a very small, and after a pair of two dissimilar metals are together adjust in a junction, and this is called a thermocouple. And when the one of the thermocouple is arranged in a series, and there a EMF is added together and give the applicable output, and this arrangement is called as a thermopiles phenomena, and shown in this figure. This is the cold junction, this is the hot junction, and when The two dissimilar metal are jointed. The free electrons are moved around the hot junction to cold junction. There is a electric or EMF is generated. So generally, the material used for is the copper. Used for metal is titanium, nickel, cobalt. This type of material used for the thermocouple. This is the nickel, chromium, silica. This is the copper or ferrous. So mainly the thermocouple can be with a first one is the Fe and constant and chromel, anomel, nickel and chromel constant and ricosil and nickel. This is the metal which are used for thermocouple. ओके आज यहाँ पर ही एंड करते हैं क्लास.